Right, so today let's look at the area of a circle. And the area of a circle is a two-dimensional measurement because you are actually measuring the flat space in between the circle or inside of the circle. So there is a formula for that. And A, which stands for area, is equal to pi times the radius squared. Now remember, in a circle, you have the radius, which is the distance from the center to the edge of the circle. And if for some reason you're given the diameter, then you would just have to find the radius and plug it into your formula. All right, so let's look at the example number 1. We're going to be given a circle that has a radius of 7 centimeters. Okay, and the problem is to find the area. So to do this, we're going to use the formula A equals pi times r squared. Pi we know is equal to 3.14. Let me write that up here just in case. And remember, that's an approximation because pi has infinitely many decimals in there. So we're going to go ahead and put down 3.14 for pi times the radius in my circle, which is 7 squared. The area equals 3.14 times 49. And so those two together multiplied gives you 154 centimeters squared. Now, I'm putting centimeters squared because this is area. If I don't put the second power, it would be a measure of a straight distance. And we want the space inside. That's two-dimensional. All right. So let's look at another example. What if they give you the diameter? And we still have to find the area. This time we're given a diameter that's got all the way across 26 inches. And to do that, we're using the same formula. Area equals pi times r squared. So area equals, we know this is 3.14 approximately. The radius. Now, I don't have a radius, 26 is a diameter. But I do know that if I only want halfway across the circle, then I do half of 26. So, the radius equals the diameter over 2. So then that's going to be 26 over 2, which is 13. 13 squared. And so now I have area equals 13 to the second power is 169. And your final answer would be 530.66. And the units are inches squared. Okay. All right, so the only difference between these two examples is you're using the same formula, but just keep in mind that if you are given the radius or are you given the diameter. So you have to make note of what it is you're given so you know exactly what to do. All right, so for example 3, it's a real life application. It says to find the area of the semicircular orchestra pit. And so you're given a stage. I guess where the performers were to perform. And then you have the stage is 30 feet wide. And then you got the orchestra pit. And it's asking us for the area of this region where I guess the fans would be cheering on the performer. What we need to do is we need to assume, well, first of all, semicircular means exactly half of a circle. So we're going to assume that it was a circular stage. We'll find that entire area with these dimensions from the semicircle. And then once we have the entire circle, we would just take half of it. Okay, so that's the plan. So we're going to take the area, which is pi times r squared, and then we're going to divide it by 2. Okay, so I'll just write here, so divide by 2 for the semicircle. Okay, so let's start finding our dimensions so we can get this formula going. If this entire distance is 30, then that means this distance is 30, because the stage is a rectangle, so one side of the rectangle is the same as the other side. And with that, we don't want the entire diameter. We want the radius. So if I know that I want the radius, that means I'm taking the diameter, which all the way across was 30, and I'm going to divide it by 2. So my radius is now 15. Okay. So now I'm ready to plug 15 into my formula. So area equals pi, which we know is 3.14, times 15 squared over 2. And that's going to be 3.14 times 225, all divided by 2. And then you get area equals 706.5 divided by 2 gives you a total of 353.25. And remember, this is area, so we're going to say feet squared. Remember, area is a two-dimensional measurement, so we got to measure it in feet squared. There you go.